Hello ninjas, let's get into another 7 Caillou series challenge. Find the missing number. The following was a question that I received during a technical interview for an entry-level software developer position. I thought I'd post it here so that everyone could give it a go. You are given an unsorted array containing all the integers from 0 to 100 inclusively. However, one number is missing. Write a function to find and return this number. What are the time and space complexities of your solution? So you'll see our method stubbed out over here. They give us an integer array nums with the idea being it'll be loaded with the numbers from 0 to 100, but one of those, it could be any of them, exactly one of them will be missing from that complete set, and so you have to find it. So I think that's clear. Go ahead and have a go and come on back when you're ready. So to start, I'll do it in the way that probably most people want to see. I'll do a LINQ solution, but I want you to know that you're not going to be able to do that if you take this seriously like it was an interview question. If an interviewer asks you to do something like this and you say, you know, what I'm about to type, chain this LINQ thing together where it's kind of this pre-baked solution that you didn't really have to think much about. It was just a matter of knowing LINQ methods. You're not going to impress anybody there, and they're going to tell you to not to use LINQ methods. It'd be the same thing, right? If someone told you to sort something and you said, oh sure, array.sort, and get up and, you know, proclaim victory, that's not going to fly in the interview. So I'll do the LINQ one first because everyone probably wants the one-liner. They like that. But if you stick around after that, we'll go through and how you could answer this in an actual interview. So let's get the LINQ out of the way. We're going to use our old friend enumerable, right? And so what's the first part of this? We have to, well, I mean, you could go about this different ways, but the way I'm going to attack it is that I'm going to build the collection of numbers from 0 to 100 inclusive. So that would be 0 and then 1, 2, 3, 4 all the way up to 100. And we know we have a method. We've used it at least a few times now. Enumerable has range. Do you remember that? We've been using that. And so you pass it your starting value, and then you give it a count of how many integers, consecutive increasing integers you want after that. And so we want to go up to 100, so we actually pass 101, right? If we only passed 100, it would go 0, 1, 2, and it would stop at 99. So hopefully that's clear why I used 101 here. They said 0 to 100 inclusively. With sets, you can also not have inclusive bounds where you wouldn't actually include the endpoints, but here you do. So that's why we have that. So if you want to do the next step, right, is how do you scan? Now remember, this range will return an enumerable collection, right? So we have some kind of collection at this point that's filled with the numbers, and you want to sort of figure out how it's the one number that it's different from the input array nums, right? So I would recommend that you go to the enumerable class documents. If you've been studying this already, you may just know a good way to go about this. But scroll down the list, see if you can find anything that looks like it might help you out. And so what I ended up with was this except. And notice that it produces the set difference of two sequences. That's pretty good, right? You have two sets, which is what we have, and I want to know what's different about them. And that's my answer, because per the rules of the problem, there's only going to be one value different. So if you'd like to read more about this except, go ahead. It's going to give you a collection. In our case, that collection should only contain one value, but you can see an example of how to use it, right? They've got these two double arrays, numbers 1, numbers 2, and they say numbers 1 except numbers 2, right? And so it filtered out that 2.2 there to give this output. So hopefully you can see how that's incredibly useful in our use case. So I'm just going to chain it on, right? Except, and then you give it the second collection, right? I already have a collection that was produced here, and we're chaining it to a second method call, and I want to pass the input array there. Now, if we trust that that they provided valid input, then this result, we saw that except returns a collection, but it should only contain one value. So the question is, remember, we have to turn the actual value. We can't return a collection because at this point we still have a collection, right? And so again, I want you to go back to enumerable, look through its methods, and think about how you might convert that to get the single element in the collection. Okay, so just scroll through your methods here and see if you can find something that would work. And where I landed was this single. Returns the only element of a sequence and throws an exception if there's not exactly one element in the sequence. I like this version because it's like error checking for me. If we ended up with more than one, imagine that in that input array, right, they had 3 values missing instead of just the one they promised, then I'm going to get an exception, and I could handle that if I wanted to. I won't in this video, but you could. And that's good. It's good to error check. So I'll go with that. Remember, this is going to return a t-source, the single element. That's perfect. We want the element, an integer. T-source, that's the generic type, remember? Single t-source, we're dealing with ints. So it's going to return an int to us. And you notice there's also a singular default. Where was that? You can look at that one. It's one where you can get null instead of throwing an exception if you don't want to throw an exception. I do in my case, so I'll just add the dot single call. And so I think we've covered everything here, right? Generate the range of values, the complete set, use except with the input array to generate a collection containing only the numbers that are different, i.e. the numbers in this set that aren't present in nums. And we're saying it better be a single, if everything's a go, and return that. And that's going to return an integer, right? Because our type here, this collection is of type integer, and so it stays integer throughout. And so I'll go ahead and run this. Sure, that's fair. What do you need to use enumerable? We didn't just make that up, right? Green, nice, and we'll hit attempt, make sure it's there. And good. So you could submit here if you just want to be done with it. If you want to take the question seriously, and I think it's worth your while to take it seriously, let's look at a way that you could actually answer this in an interview without being laughed at. I mean, these guys, they're going to go, no way, buddy. No way are you getting away with that here. We want to make sure, you can write out, you can process this yourself. Because remember, when people hire you, they're going to ask you to solve things that people haven't solved yet. And so you won't always be able to go to a library, some pre-built solution that someone made for you. So let's do this, right? We'll use the same kind of idea, though, and build up a collection that has all the values in it. And then we'll kind of scan the input collection and figure out what's missing. So we recently used a collection called a hash set, and I find that to be helpful in this case too for generating that collection from 0 to 100, because we don't need any duplicates, right? We just want the set of numbers. And before we even get going, actually we're not going to use LINQ anymore. Collections, generic is when you want to use those built-in collections like hash set and list and dictionary. So hash set, we're dealing with ints, right? And I'll call mine, let's call it 0 to 100. It's just going to contain that set of numbers to start. Remember, we got to initialize this. We've got to allocate memory. That's just how we start, right? So by creating it, now we can actually use this 0 to 100. Good. And one thing I'm going to do, we'll get into a little bit of detail here. I pulled the hash set document page up, and since we're in a fortunate place here, we know the size of the input. They guaranteed it for this problem. Oftentimes you don't. Sometimes you can make a good guess or you have a good idea, but I want you to know something with the hash set class. Let's go to the constructors. You can just have the empty parenthesis, right? That's how we've been using it. But there was one overload I wanted to show you with an integer. Look at this. If you pass an integer in the constructor, it reserves space for that many items. They call that the capacity of the collection. That's a common term for that. Remember, the capacity is different than the count. The capacity is how many spots are saved that are available for the collection. You may have only inserted 2 items in, but let's say you reserved 101, right? And you start adding items to it. And, let's say you filled up 5, and if you ask the hash set how many elements it has in it, the count, it's going to say 5, but please note that's different than the capacity. Capacity is how much memory it has allocated at the given time. And so since we know we're going to be dealing with 101 integers, let's go ahead and set that capacity. And you don't really see this, but you can imagine as we're inserting, or as you're working with a hash set, once you exceed that capacity, it's got to reallocate memory, it's got to get a bigger chunk. And so there's a performance cost for that. So if you know the size of your collection, you can avoid all that and just set it up right to start and not waste memory that you don't need. So let's do that. Let's just give it 101, right? For this problem. Okay, good. So now we've got this hash set. The hash set won't contain duplicates. There are some other benefits here. It's very efficient for adding values, for removing values, and for checking if values are present in the collection, which is incredibly relevant to this problem, right? So the next step, let's go ahead and add those. Let's populate the 0 to 100 array. So I'll just do it with a simple for loop, right? I is less than, we'll say less than or equal to 100. That'll get us 101 values. I plus plus, and we could say 0 to 100 add I, right? Be 0 the first time, 1, 2, 3, it'll get up to 100, get up to 101, it'll break out because that's not less than or equal to 100. And you've got a full hash set there. So we have all the values now, right? So given that, once we have that, we can iterate over the collection, the integers and nums, right? And we could sort of check it against our list here, right? And we could say, or instead, by checking it, I mean, we'll check the collection if it's present. If it is present, then we can remove it from the collection, right? So if, let's say the first number was 5, these may or may not be in order. Let's say they weren't in order, and so the first number is 5, right? We'll go into our hash set. We had already loaded all the values, and so you'll pull 5 out, right? And the idea being is, after you've gone over this whole nums collection, there should only be one value left, the one that you never pulled out of your full set, and then we'll just return that. That's how I'll do that. So let's go over and n in nums, right? Let's go over that collection and do what I proposed. So there's 2 cases, right? This value n that we have at any given iteration, it's either in our set or it's not. And so it better be in the set, right? If nums is a valid entry, it doesn't have duplicate values, it doesn't have values outside 0 to 100, stuff like that. So this gives us an opportunity to do that error checking that we really should always be doing, that input validation. So we could say 0 to 100, and then let's go to hash set just so we know what we're doing. If you look in its methods, contains. So you can check if a value is present in there. And you'll see it just returns a Boolean, true or false. It's perfect, right? We give it a value that we're looking for. Where are they using it? If it, yeah, numbers contains, and you just say the number you're looking for, and it will return true or false. Perfect. 0 to 100 contains n, right? If it does contain that value, we simply want to remove it, right? 0 to 100, remove that value. And that's progress. So let's go to, just so you can see, there's also a remove here. So if you want to look up remove, you can do that. It returns a true or false if it was removed. If you wanted to do something with that Boolean result, you can. I'm not going to, I'll just ignore it. And you can look at examples down here if you like. And then, so the other case was that we didn't find it in our collection. That means they gave us bum input, right? So let's just throw an exception for now. To throw a new, I'll pick argument exception. They gave us a bad input. And we'd say something like found invalid input value. But, you know, something meaningful to you, right? And so good. This, and I'm sure this will happen, Code Wars is usually good about that. But in real life, we always check, right? But we'll never hit this. So, but it's there to protect us if something went wrong, if you use this code in the field in real life. So then, after processing, right, we should only have one value left in our 0 to 100 set after this has gone through all the nums. And they gave us good input. There's just one value left. So what remains to do then is to get that last value. And so what I'm going to do is I'm going to enforce that. This is another way of checking that they didn't give us bad input. If it has more than one value, or yeah, if there's more than one value remaining, then we definitely have a problem. It means they didn't give us enough numbers. So you can say, I'm sorry, 0 to 100 dot count, right? That's a property. You don't have to believe me. You can go right in your group here. But remember, I said it was a property, so you would go under properties. Be sure if you not seeing something that you expect, you know, check if it's a property count, and you can look that up if you'd like. Pretty simple. It tells you how many values are in the set. If it's not equal to 1, Houston, we have a problem again, right? So we could use that same, let's just throw the exception again with a more appropriate message. And we could say something like, only one number was supposed to be missing from input, or whatever you like. Whatever that when you see it, you're going to know what's going on. All right, so we verified that. If we survive this, which we will, because they're going to ensure that in this little sandbox environment for us, we know that 0 to 100 has only one element at this point. And so hash set's a little bit different than collections like arrays. You can't just say, you can't just say 0 to 100, 0, you know, give me the first element. You're going to run into trouble there. So what I'll do to get around that limitation is that I'll just iterate over the collection of size 1. I'll initialize this with some bogus value, then I'll say for each int n in 0 to 100. We know it's only 1, so this is only going to execute once. Result equals n, right? That should be fine. I'm just going to do once and then return the result. And so if we test this, we'll see if we're okay. green, very good. And so we're clear to launch. Maybe I'll submit it this way, just to look more like an interview solution. Yeah, but anyways, so the other part of this, if you were interested, was that they asked you to talk about the time and space complexities of your solution. And so there are a number of ways you can go about this, but you want to think about time and space, right? You won't always have just 100 elements. You could have 4 million elements, and then it's going to matter how you go about solving this problem. And so in our case, what did we do? We made this new collection. When we're talking about space complexity, we made this extra collection, right? 0 to 100, it had 101 integers in it. And so you're not expected to know, what size an integer is on a system. Let's say it's 4 bytes is your integer size, but it could be different on a different operating system. But if you just said, assume 4 bytes, we had 101 of these integers, so I used 404 bytes of memory for this collection, right? And that's really the only space. I mean, you made a one integer here that I don't think anybody's going to care about, just to get the result, but you could say 405 if you want. And so that kind of covers the memory usage that you're using. In terms of time, you'll find out that the document pages are actually very helpful with the collections. So as far as the code that we wrote, you can see our solution comes down to basically looping over 2 collections, right? We've got this for loop, and we've got this for loop. Now we've got that third, but it's just one element, so it's going to be like constant time. You don't have to worry about it. But these ones can be of size n. Again, we got lucky here. It was fixed size of 100, but in a general sense, it's size n, whatever the size of nums is. So you could say that runs in O of n time, where in this case n is 101. In terms of the hash set operations, check this out. So we'll go back to methods. When you go to add, check this out. Scroll down a bit. This should tell you, here you go. When you get down to the remarks, they'll tell you it's a big O of 1 operation, which is outstanding. I mean, if you can get work done with, that's considered constant time. So it's just, split second, it's a single operation. You basically don't even have to worry about it. It's negligible. And if you haven't heard of this big O notation, go ahead and Google that on your time. It's a way of measuring the efficiency of algorithms. That's common language in the industry. If you're just a programming hobbyist, you probably don't need to learn it. But if you plan on taking programming seriously, doing it professionally, you're gonna want to dig in and learn about that notation. But know that O of 1 is very good. So, but we talked again, remember when we were talking about capacity. Take the note here. If the object must be resized, the hash set object, this becomes an ON operation, where n is the count. So that was kind of the motivation where I sized the hash set appropriately so we could avoid any kind of resizing. Now, if I hadn't put that capacity in, would they have defaulted it to a size that was big enough? Maybe. I don't know what they do under the hood. But it's good practice, right, where you specify that. So I'm going to claim that all of ours is a O of 1 operation. And that's good. That's very fast. You could basically ignore it when it's O to 1. But go ahead and go through the other methods that we used, right? We used remove. And you'll find that remove it's an O of 1 operation. Beautiful. And what was the other one? Contains that we used? Let's make sure that is. And this is the beauty. Contains. It's an O1 operation. And that's the beauty of a hash set, is that because of that hashing algorithm, it can get to values very quickly. And so it doesn't have to start at the beginning of the collection and search for the values. It can get there immediately, and that's how you get this really good performance for these kind of operations. So basically we can just call this O of n. There's no added complexity here by using the add method. Same for contains, same for remove. I'm gonna call those constant time. We basically got another O of n, right? There'd be 100 in this one because one was missing. There was 101 in the first one, but basically they're both, you can think of them like 100, right? You can think of it as complexity O of n for this loop, O of n for this loop, right? That's the thing with the big O notation you'll find out, which is confusing at first, but it's actually very convenient, is that you can drop sort of little mathematical values that don't really matter in the grander scheme of things. You know, we could just call it both of them n, close enough, right? One's n plus 1, one's n, you know, plus 1, really, who cares when you're dealing with n that equals 4 million, right? Does plus 1 really matter? No. So we could call that O of n plus O of n, O of 2n, right? And then again, the 2n, do you really care? In the grand scheme, no, so you could call it O of n. It makes sense when the input sizes are very large. And then, you know, below, we're not really doing anything of substantial work. We're checking the count, which is O of 1, immediate. We're doing a loop here, but don't be fooled, right? We guaranteed at this point it's exactly size 1, so you're looping once. It's not a typical loop case. So I'm going to call that negligible 2, and then return the results nothing. So yeah, I would call it like an O of n solution. And our space complexity was, you know, however many integers, 404 or 405, whatever you want to call that. So hopefully that gave you some insight. Definitely look up the big O if you're serious about this game, and hit me up with questions. I'll go ahead and submit mine the way it is, this way. You know, to look through the solutions, see if there's anything else you can obtain for future use. So, well, that's clever, right? That's really clever. They got the clever vote. Not a best practice though, right? Because it's like, if you're just coming and looking at this, you're like, whoa, what's this magic number 50-50? You know, but that would deal with the sum of all the integers from 0 to 100, right? So he got that number. Yeah, that's super clever. So yeah, cool stuff to just look at. And then yeah, like we knew the one-line Wallies were coming, right, with the LINQ solution, but you are getting thrown out the door if you do this at the interview. I mean, they won't literally throw you out the door, but they're gonna say, come on, you're not getting away with that. You know, write it up on the whiteboard how you do it. So yeah, see what you can learn from these. Otherwise, you know what to do. Hit me up with questions, comments, feedback. I appreciate all of it. Likes, subscribes. Thank you very much. And I will see you in another video.